What is up, everyone? Mr. Skelton here, back at it, Unit 2, Lesson 8, getting into the beginning of matrices. And we're going to talk about some basics of matrices, and then we're going to get into adding and subtracting them. So really the first thing, I didn't put the learning targets on here, but the first thing we want to do is to be able to identify a matrix. We do that by row, by column, and I'll explain that. We want to identify by row, by column. And also we want to identify the elements within the matrix, and then two, we want to be able to add or subtract matrices. Okay, so those are the two goals for today. In the first slide, we're just going to talk about what a matrix is, and no, it has nothing to do with the movie. We're taking a red, or I think it's red or blue pill. Gosh, I haven't seen that movie for years. But anyways, has nothing to do with the matrix as an alternative universe or world, but how we apply them mathematically speaking. So, taking a look at the first slide here, placing a data in a matrix. What is the definition of a matrix? And here it is, right here. It is a rectangular array of numbers. And the biggest thing that you need to take away from this is that a matrix is identified or named by their rows and columns. So this is an example of what we would call a 2x3 matrix. Essentially, you just have numbers in a rectangular or square fashion, and they're centered around brackets. These are brackets here. Okay, so another way, if I want to emphasize this a little bit better, you see brackets like this. So that would be a 2x2. So the first thing I want you to understand and learn how to do is that you have to identify or name them rows by columns. Okay, and you have two rows, 1, 2. Remember, rows always go left to right, so that's a row, and then a column. Just think of like columns in a house or columns on like a building. They go up and down. So this is 2 rows by 3 columns, 1, 2, 3. All right. So when you identify, like if I gave you that right there, well, that's kind of easy, but something like that, I would say, okay, how would you identify that matrix? That is a 2x3. Why? Because there's 2 rows and 3 columns. This is a 2x2. You have 2 rows and you have 2 columns. This is a 3x3 here. Okay. Ones that can kind of mess with students a little bit, I'll give you an example. So if I ask students to name or identify that matrix, how would you identify that? Well, how many rows? There's 1 row going across. How many columns? 1, 2, 3, 4. That would be an example of a 1x4. And you always write it as rows by columns. Okay? So moving forward, that's just to kind of get an idea what a matrix is. Just an arrangement of those numbers. Once we know what a matrix looks like, we want to be able to identify certain elements. Each one of these numbers, like 11, 21, 9, and etc., each one is considered an element within the matrix. Now, the way you name a matrix is with a capital letter. Okay? And when you talk about an element, you use a lowercase letter. And so you can see here, it says A sub 21. Now what this A sub 21 means, I'll do it right here. That means second row, first column. If I could spell column. Okay? So the 21 is not really a 21, it's 2 and then 1. So what that means is we want to figure out what that element is. Now we know the answer is 23, but it's the second row, so 1, 2. So in the second row, it's the first column. So it's here, and it's where they kind of meet, which is 23. A sub 13, what does that mean? That means the first, what is the element in the first row, second column? First row, or sorry, first row, third column. First row, third column, that would be a 9, okay? Why don't you go ahead and hit pause and try A sub 23, A sub 12, and A sub 42 and check back with me. Okay, so A 23 would mean the second row and the third column, which would be a 27, which is right there. A sub 12 would be the first row and second column, which would be a 21. And A sub 42 would be the fourth row, 1, 2, 3, 4, and the second column, which would be at 4, and that would be our answer there. So that's identifying an element within the matrix. Now this second This second example is just real basic. It's just to get you to identify the numbers and what it means if we applied it to the real world. So we have teacher A, B, and C. So you know this would be like myself and Mr. Panning and Mr. Middleton, okay? And how would you use these rows by columns to identify which each teacher has? For example, you know, Mr. Skelton bought 3 rolls of tape, 2 staples, 25 cases of pencils, and 2 cans of whiteout. Mr. Panning had 5 boxes of tape, 2 staples, 20 pencils, 1 case of whiteout. Mr. Middleton is the third column. 4 goes with him, 4 tapes, 1 pencils, or 10 pencils, 1 staples, and 2 whiteouts. So you kind of get the idea there. It's just being able to apply a real world situation to a matrix, make sure you can identify the elements that go with each row and column, okay? Next, we're going to get into adding and subtracting matrices. Here's what you need to make sure you do. You need to make sure you have the same matrix, okay, matrices when adding and subtracting. What I mean by that is, for example, if you look at number 1, I always identify the rows by columns. That's 2 by 3, so that's a 2 by 3. This has to be a 2 by 3, and your final answer is going to be a 2 by 3. You can't add or subtract, okay, different identifications of matrices like a 3 by 1 plus a 2 by 4. You can't do that. They have to be the same. 2 by 3 gives you a 2 by 3. Even when you're doing subtraction, you can see here this is a 2 by 3. Or excuse me, this is a 3 by 2 here. This is a 3 by 2 here. This is a 3 by 2 here. When you're adding or subtracting, they have to be the same, okay? Which, when we get to multiplication and division, it's a little bit different. So, all you do here is you add the common elements together. What I mean by that is, if you have 2 here, which is in the upper left-hand corner, or A, all right, if we went A 1 by 1, then you add it with A 1 by 1 here, so 2 plus 7 would give you 9. 3 plus 8 is 11, and you can do this in any order, right? I could go 4 plus 6 and put 10 over here on the far right. -3 and 1 is -2. I could go -2 and 4, which is 2 here, and 5 and -2 is 3. So you can kind of, you know, do it any way you want. Just make sure you're matching up. You know, I'll put a triangle here, I'll put a triangle here, I'll put a square here, I'll put a square here, I'll put a circle here. It has to be the same, in the same location in the other matrix that you're adding or subtracting together, all right? Excuse me. Now, number 2 looks a little bit challenging, but I think you'll pick up on it fairly quickly. You have to find W, X, Y, Z, M, and N. So, using that same logic I just used up here, let me just double check 3 by 2, 3 by 2, 3 by 2. Okay, I'm good to go forward then. And then we're matching up our elements in each matrix. So 10 minus W equals 6. And we just write it out like that. 10 minus W equals 6. And solve for W. So I'd subtract 10. I'd get minus W equals a -4. So W is going to equal 4. Awesome. Let's go to the, this would be basically A12, or be the first row, second column would be A12. So X would match with 5, which would match with -2. So it's going to be X minus 5 equaling a -2. So I'd add 5 over there, and 5 and -2 would make 3. So X is 3. Now when you get down to W, I'm going to have W minus X. Now what is W? You know what W already is, right? It's 4. So this is really a 4. This X right here is really a 3. So it's 4 minus 3 equals Y. So 4 minus 3 is 1, so Y would equal 1. To find Z, I would go 12 minus Y. Now we already know what Y is. It's a 1, so you can put a 1 in there. So it'd be 12 minus 1 equals Z. Well, 12 minus 1 is 11, so Z would equal 11. Down here with Z, we just found that to be 11, so I'm going to put that in. So I'm going to have 11 minus 10 equals M. So M would equal 1. And then since M is a 1, I'm going to go M, which is a 1, minus W equals N. What is N? N is n. Oh, we found w already. It's 4, right? So I should have put a 4 in there. So it's 1 minus 4 equals n. So n equals negative 3. And I think that's all of our letters. Okay. Down here, this is kind of, again, just an application, real basic question on matrix addition. So you have two matrices. It says the following matrix represents the number of spectators that have attended the first 4 football games this year. This is assuming we're at Homestead. Okay, so we have basically game 1, game 2, game 3, and game 4. Since it says the first 4 games, you have home and visitor. So let's identify this matrix in terms of its rows by columns. There are 2 rows, so this would be considered a 2 by and 1, 2, 3, 4. This would be considered a 2 by 4 matrix. And then down here it says this matrix represents the number of people who have attended the first 4 football games at Carroll, all right, our biggest rival. And again, that would be game 1, game 2, game 3, and game 4. And it says what is the sum for both schools? Probably not the most perfectly worded question. You could interpret this a couple different ways, but again, if we're going to back to the point of making sure that if we're going to add matrices together or subtract them, then a 2 by 4 plus a 2 by 4 has to be a 2 by 4. So essentially what we're going to do here is just add up those numbers. So you can keep this as home and visitors. All right, and this would be game 1, game 2, game 3, and game 4, and we're just going to add those up together. So 338 plus 212 is going to give me 550. And I'll go game 1 visitors. So 118 and 180. 118 plus 180 is going to give me 298. For game 2, the home was 415. The home here was 310. So 415 plus 310 is going to give me 725. Visitors would be 82 and 92. So that's going to give me 174. Game 3, home would be 512 and 316, so 512 plus 316 is going to give me 828, and visitors would be 68 and 86, 68 plus 86 is going to give me 154, and for game 4 you have 311 and 158, which is 469, and visitors would be 76 and 144, which gives me 220. Now, this says, what is the sum from both schools? In my mind, if I interpret that, it kind of makes me think, okay, how many people have attended the games, up to this point through game 4? You could add up all these numbers and get a total number of people at the game, which again, this is probably a poorly worded question. This is what I wanted to see here. I wanted to make sure that we're multiplying that we're adding those matrices together, okay? So a real basic lesson on matrices and matrix basics. I do want to make sure that you understand this. I didn't say this, but when we were just talking about a single matrix, obviously we call that a matrix. When it's more than one, we call those matrices, is the correct way to say that. I did not specify that in the beginning, okay? All right, if you have questions in class, let me know, and we will continue forward. See you.